Good morning, dear students. Last class I have told about different types of problems on increasing functions and decreasing functions. We selected those problems from exercise 6.2 and how we are going to showing the given functions or increasing functions, that is strictly increasing functions and strictly decreasing functions in their intervals. If the differentiable function is less than 0 means, then we are calling that function f of x is a strictly decreasing function. If the differentiable function is greater than 0 means, then that function is called as a strictly increasing function in that interval. Like that, we have finished some different types of problems on increasing and decreasing functions. Today also we are going to solving some different types of problems on increasing and decreasing functions. How we are going to showing in their intervals, and before that how we are going to finding their intervals. After finding those intervals, in those intervals how we are showing that given functions are increasing and decreasing functions. About all these today we will discuss. Now let us, we are going to solving some different types of problems on strictly increasing functions and strictly decreasing functions. The first question is, find the intervals find the intervals find the intervals find the intervals in which the function f given by f of x is equal to 2x cube minus 3x squared minus 36x plus 7 is first question is strictly increasing and second question is strictly decreasing. First question is strictly increasing. Second question is B is strictly decreasing. Strictly decreasing. Like that, they are asking two questions here: strictly increasing and strictly decreasing here. See here, to that given function we must take here differentiation with respect to x, and afterwards for increasing or decreasing directly we are equating to 0. With help of that we are going to finding some values for x, and after getting those values, just we are going to plotting them on real number line. After plotting those real numbers on the line, we are getting some intervals. In those intervals we are going to showing which is strictly increasing and which is strictly decreasing here. Like that we are giving solution for this question. Now let us, we are going to giving the solution for this question now. Solution: let the given function f of x is equal to 2x cube minus 3x square minus 36x plus 7. Differentiation with respect to x. Then f dash of x is equal to 6x square minus 6x minus 36. F dash of x is equal to, take 6 common, then we will get here x square minus x minus 6. At the same time, we got here a quadratic polynomial function. When you are getting quadratic polynomial function means we must and should convert into product of factors. See here, at the rough side we are going to converting that into product of factors, that is x square minus 6x minus 6. X square minus 6 minus 6 is there. For that we are going to converting into minus 6. This is x square minus 3x plus 2x minus 6. X take common, then we will get here x minus 3 plus 2 take common, here x minus 3, and again x minus 3 take common, you will get here x plus 2. Like that we have product of factors for the given quadratic polynomial function here. So here f dash of x is equal to 6 into, and for this part, in bracket part, we are going to writing a product of two polynomials. They are x minus 3 into x plus 2. At the same time, you consider it is equation number 1. Number 1, this is f dash of x equal to 6 of x minus 3 into x plus 2 now. For increasing or decreasing, for increasing or decreasing, for increasing or decreasing, for increasing or decreasing, f dash of x is equal to 0. Then if you can equate to 0, 6 into x minus 3 into x plus 2 is equal to 0 here. That is, you are getting here x minus 3 is equal to 0 or x is equal to 3. And one more, x plus 2 is equal to 0 and you will get x is equal to here minus 2. And we got the two values here, minus 2 and 3. After getting that, just you plot them on the real number line here. Here one side is minus infinity and one side is plus infinity, and between them is first will come minus 2, next will come plus 3. Like that here, 3 intervals we are getting here. One is minus infinity comma minus 2, second one is minus 2 comma 3, third one is 3 comma infinity. Like that we have, at the same time we got 3 intervals. In those 3 intervals we are going to checking the given differentiable function f dash of x is less than 0 or greater than 0. In the previous class we have taken one table. Here also we are going to taking one table here. With the help of that table, easily we can tell in which interval the given function f of x is strictly increasing or strictly decreasing here. First one is table here. First one is intervals. intervals next one is sine of f dash of x, sine of f dash of x, nature of f of x here, nature of f of x here. First interval is minus infinity comma minus 2. Second interval is minus 2 comma minus 2 comma 3. Third interval is 3 comma plus infinity. Like this, yes. Minus infinity comma minus 2. Before minus 2, generally which numbers will come here? Minus 3, minus 4. Like that we can represent also, no problem. Minus 3, minus 4, like those numbers will come. You can select any one number, minus 3. Just you can put substitute here, minus 3. Minus 3, minus 3. Minus 6 means negative. Minus 3 plus 2 means minus. Minus 1 means minus will come. Minus to minus plus. Plus means it is the positive. Positive means we can write f dash of x is greater than 0. If it is greater than 0 means what we can write? Strictly increasing function. Strictly increasing function. Otherwise simply you can write strictly increasing here. Not only minus 3, you can take minus 4, or you can take minus 5, or you can take minus 6, or you can take minus 7. Like that among all the numbers from minus 3 onwards, you can take any number in that interval. Next interval is minus 2 comma 3. In this minus 2 comma 3, what are the numbers between minus 2 and 3? You can select any one number. Generally, between minus 2 and 3, you are seeing numbers minus 1, 0, 1, 2. Minus 1, 0, 1, 2. Between those are so many real numbers will come. Just you have to select that number only before 3. What is the number before 3 generally? 2, 1, 0, minus 1. Among all these 5 numbers, you can select any one number. Say you can select plus 2 here, 2. 2 minus 3. 2 minus 3 becomes minus 1, means minus. 2 plus 2 plus 4. Plus 4 becomes plus. Minus into plus, minus. Minus means it is the negative. Negative means we can write here f dash of x is less than 0. If it is less than 0 means we are calling that function is a strictly decreasing function. Otherwise simply we can call it as a strictly decreasing. Next one is 3 comma infinity. After 3 and before infinity. After 3 generally numbers will come 4, 5, 6 like those numbers. Among all those numbers, you can select any one number. 4 you can select, 5 or you can select 6 also, no problem. My wish, I am going to taking 4 only here. Now 4 minus 3 becomes plus 1. We can write plus here. 4 plus 2 means plus 6. It is also plus here. Is equal to plus into plus. Plus. Plus means here positive. Positive means we can take f dash of x is greater than 0. If greater than 0 means we are calling this function as a strictly increasing function. Strictly increasing function. Strictly increasing function. Like that we are showing strictly increasing and strictly decreasing function. After finding that, generally we are going to writing in case of union symbol. The given function f of x is strictly increasing in the intervals minus infinity comma minus 2 union 3 comma infinity. Like that we are writing. I will show how to write about that also. See how we are going to representing now, strictly increasing and strictly decreasing. About that I will tell you now. Therefore, f of x is strictly increasing function. Strictly increasing function. Strictly increasing function. Increasing function in the interval minus infinity comma minus 2 union 3 comma infinity, and f of x is strictly decreasing function. Strictly decreasing function. Strictly decreasing function in the interval minus 2 comma 3. Between only in the open interval minus 2 comma 3, in that interval only we are getting strictly decreasing, but in remaining two intervals we are getting strictly increasing functions. Like that we are showing a strictly increasing function and we are showing the strictly decreasing function. Like that we give solution for this question. Let us now we are going to solving another questions. Find the intervals. Find the intervals. Find the intervals in which the function f is given by f of x is equal to x square plus 2x minus 5. 5 is strictly increasing. First question is strictly increasing. Second question is strictly decreasing. Like that they are asking two questions for this. X square plus 2x minus 5. Same for this also. Here we are going taking differentiation with respect to x here. So here Before this, how we solved some questions on strictly increasing function and strictly decreasing function, and for this also we are going to taking a same procedure of solution for this question also. Let us we are going to giving solution for this question. Solution is, let the given function f of x is equal to x square plus 2x minus 5. Differentiation with respect to x. Then f dash of x is equal to 2x plus 2. D by dx of x square is 2x and 2x difference is 2 here. This is equation number 1. For increasing or decreasing, for increasing or decreasing, for increasing or decreasing, for increasing or decreasing, f dash of x is equal to 0. Then if we can equate this is equal to 0, there you are getting the value for x is minus 1. Two x plus 2 is equal to 0. 2x is equal to minus 2. X is equal to minus 2 whole dividing plus 2 gets cancelled, and x is equal to, we got the value of x is minus 1. At the same time, just to plot that number on real number line like this. Here minus 1 here will come. This side is plus infinity and this side is minus infinity here. Otherwise you can write down also, no problem here. Like that here we are getting two intervals, minus infinity comma minus 1 and minus 1 comma plus infinity. Like that we got the two intervals here. Now we are going to drawing the table. In that table only we are going to representing and which is strictly increasing and which is strictly decreasing corresponding to their intervals here. Now let us we are going to giving table for those functions. Tables now. The table. First column is intervals. Second column is sine of f dash of x. Sine of f dash of x. The third column is nature of f of x. Nature of f of x. First interval is minus infinity comma minus 1. Second interval is minus 1 comma plus infinity. Like that we have, and at the same time we got the two intervals. So here between minus infinity comma minus 1, before minus 1 generally we are getting numbers like this: minus 2, minus 3, minus 4, up to and so on, like those numbers, up to and so on, like those numbers here. And after minus 1 we are getting here 0, 1, 2, 3, up to and so on, like these numbers. Now for the first interval minus infinity comma minus 1, for this interval just to select any one number, minus 2 or minus 3 or minus 4 or minus 5 or any one number. My wish, I am going to selecting minus 2 here. Just bring minus 2 and substitute here. 2 into minus 2. Here if you can substitute, here f dash of x equal to 2x plus 2, we have no. In this case we are going to substituting here, f dash of minus 2 is equal to 2 into minus 2 plus 2. Minus 4 plus 2 becomes minus 2 is less than 0. That's what here. Minus 2, negative symbol we got here. Negative symbol means we are writing here negative. At the same time, we are going to writing about the differentiable function is f dash of x is less than 0. If it becomes less than 0, we can call that function as strictly decreasing function. Strictly decreasing function. Strictly decreasing function. Now minus 1 comma infinity. After minus 1 generally we are seeing the number 0 comma 1 comma 2 comma 3 up to and so on. You can select 0 or you can select 1 or you can select 2 or you can select 3, like those numbers are there. You can select any one number here. See here, my wish, I am going to selecting 0. 0 if you can substitute here. For second interval, I am going to substituting here f dash of x equal to 2x plus 2 is there now. Substitute here f dash of 0 is equal to 2 into 0 plus 2 is equal to 0 plus 2 becomes 2. Plus 2 we got. Plus 2 means we can take here plus symbol. Plus symbol means we can write positive here. So what here we can write f dash of x greater than 0. That is, if the differentiable function is greater than 0 means we can call this function as a strictly increasing function. Strictly increasing function. Strictly increasing function. That's what we can tell. F of x is strictly decreasing function in the interval minus infinity comma minus 1. At the same time, we can take a strictly increasing function in the interval minus 1 comma infinity. Like that we are giving solution for this question. And firstly, we have written that given function. To that function, we have taken differentiation with respect to x, and afterwards, for increasing or decreasing, we equated that differentiable function is equal to 0. By equating that value, that variable function is equal to 0, we got the value for x is minus 1. And after getting that, we plotted that on real number line, and afterwards we got the two intervals. In those two intervals, we checked which is strictly increasing function and which is strictly decreasing function. Here we have written those intervals also here. Like that we give solution for this question. Let us now we are going to solving another questions. Find the intervals. Third question. Find the intervals in which the function f is defined by the function f is given by is given by f of x is equal to f of x is equal to minus 2x cube minus 2x cube minus 9x squared minus 9x squared minus 12x plus 1 is first question is strictly increasing or decreasing also they're asking here. Increasing. And second question B is strictly decreasing. Strictly decreasing they're asking here. First one is same thing how we solved before this some questions now. Similarly in the same way we are going to giving solution for this question also here. Already we have finished some different types of questions in a linear polynomial function, that is in case of linear polynomial functions, in case of quadratic polynomial functions, and now we are going to solving this cubic polynomial. It is the cubic polynomial. Even we have finished one problem on cubic polynomial also. Now let us we are going to solving the question also cubic polynomial. That's what we are going to giving the solution for cubic polynomial now. Let us now we are going to giving solution for this question. Solution is, let the given function f of x equal to, let the given function f of x is equal to minus 2x cube minus 9x square minus 12x plus 1. Differentiation with respect to x. F dash of x equal to minus 6x square here. D by dx of x cube is 3x square. Already minus 2 having product with that, no? That's why finally we can write this is minus 6x square minus 18 minus 18x and minus 12, and the last one is independent constant 0. F dash of x is equal to, take minus 6 common from all these three. We can take here x square minus plus 3x and minus become plus 2 here. It is the quadratic polynomial we got. And when you are getting a quadratic polynomial in case of differentiable functions, try to convert them into product of factors. We got bracket part is x square plus 3x plus 2. That's what here we are going to converting that quadratic polynomial into product of factors. We are going to solving that part, we are going to giving the solution for that part at the rough side of the solution of the problem here. Say here x square plus 3x plus 2 here. 2 into 1 2. For 2 factors will come generally here. X square plus 2x plus x plus 2 here. X take common here, x plus 2. And remaining is x plus 2 here. And take x plus 2 common, and then you will get x plus 1. Like that we got here. This is. Now we are going to substituting those factors in place of bracket part for the differentiable function. F dash of x is equal to minus 6 into x plus 2 into x plus 1. At the same time, we represent this equation number 1. From that part only, we are going to take in the values for x. Next step is for increasing or decreasing. For increasing or decreasing, for increasing or decreasing, f dash of x equal to 0. That is minus 6 of x plus 2 into x plus 1 is equal to 0. Otherwise, you can set that side. We can write here x plus 2 is equal to 0 or x is equal to minus 2. Next one is x plus 1 is equal to 0 or x is equal to minus 1. We got the two values, minus 1 and minus 2. These two are values for x. And afterwards, we are going to plotting on the real number line like this. It is the real number line with the help of these two values of x. Real number line here. One side is minus infinity, another side is minus infinity. Another side is plus infinity. The first number is here minus 1 and next number is minus 2, like those will come here. Totally we have here 3 intervals, and in those 3 intervals the function f of x is whether it is strictly increasing or strictly increasing. About these two we are going to checking in those 2 intervals here. Now let us, we are going to giving table also. With help of that table only, we are going to representing that the given function f of x is whether strictly increasing or strictly increasing. About these two we are going to deciding to the function. Let us now, we are going to giving the table for this problem. The table here. See here, one is intervals. First column is intervals. Second column is sine of f dash of x. The last column is we can write strictly increasing function. Strictly nature of the function. Now the first column is intervals. Next one is sine of f dash of x. Next one is nature of f of x. Nature of f of x. First interval is minus infinity comma minus 2. Second interval is minus 2 comma minus 1. Third one is minus 1 comma infinity. Like that we have 3 intervals here. Minus infinity comma minus 1. See, if you can observe, differential function from equation 1, first symbol is minus is there. That's why it is common to every interval. It is common to every interval here. Minus infinity comma minus 3. Before minus 2, generally numbers will come minus 3, minus 4, minus 5, like those numbers will come in this interval. My wish, I am going to selecting minus 3 here. Put minus 3 here. Minus 3 plus 2 minus 1 means negative. Minus 3 plus 1 minus 2 negative. That is minus to minus plus, plus to minus plus. It is the plus means positive. We are calling this as the positives. Positive means what we can write? Minus, it is minus. Minus to minus plus, plus to minus minus. Minus means we can take here negative. Negative means we can write f dash of x is less than 0. Less than 0 means what we can write? Strictly decreasing function. Strictly decreasing function. It is 1 enough. Next one is minus 2 comma minus 1. Between minus 2 comma minus 1, generally minus 1.5 will come here. Before minus 1, minus 1.5. Substitute here minus 1.5 plus 2. Minus 1.5 plus 2 means plus 0.5 will come. That is plus symbol. Minus 1.5 plus 1. Minus 1.5 plus 1 means minus 0.5. It is the minus. That's why minus to plus minus, minus to minus plus. It is the positive. That's what we can write here. It is the positive. Positive means we can take f dash of x greater than 0. Greater than 0 means what we can write? This is a strictly increasing function. Strictly increasing function. Strictly increasing function. It is. Next one is minus 1 comma infinity. After minus 1 and before plus infinity. Generally 0, 1, 2, 3, 4 numbers will come. After minus 1, you can select 0, you can select 1, you can select 2, or you can select 3 as your wish. That should be after minus 1. That's after minus 1, 0 will come. That's my wish. I am going to selecting 0 here. 0 plus 2 means plus 2, plus symbol. 0 plus 1 means plus 1, plus symbol. Plus into minus into plus minus, minus plus minus, minus will come here. That's why we got here negative for the last third interval. That's what we can take here. F dash of x is less than 0. If it is less than 0 means what we can write here? Strictly decreasing function. Strictly decreasing function. That's why strictly decreasing function in the interval minus infinity comma minus to union minus 1 comma infinity. But strictly increasing function will come in only one interval minus 2 comma minus 1. Like that we are going to writing the intervals for the given function. See how we are going to writing those intervals. I will show you now. Therefore f of x is strictly increasing function. Increasing function in the interval minus 2 comma minus 1 and open interval minus 2 comma minus 1 and f of x is strictly decreasing function, decreasing function in the intervals minus infinity comma minus 2 union minus 1 comma infinity. Like that we are going to representing the intervals for strictly increasing and strictly decreasing function. Similarly, if you can see like all these questions, if you can just solve them at your home, because I have finished quadratic polynomial problems, I have finished cubic polynomial functions, like those I have finished some different types of problems finished with respect to strictly increasing functions and strictly decreasing functions. That next class also will solve some problems only, one or two problems on strictly increasing or strictly decreasing questions. Then afterwards I'll start new lessons, that is the tangents and normals, how to find out the slope of tangents and how to find out slope of normal. At the same time, how to find out equations of tangents and normal. About all these we will discuss on next class. Thank you very much.